Hey everybody, welcome to today's Kubernetes Masterclass. Really glad to have you all on the line. We have about 90 minutes together, and for those who are joining, I want you to know that this session is being recorded, so you will receive the recording and the slides afterwards if you have to jump off. Today we're going through applying the site reliability engineering golden signals to your Kubernetes cluster using Prometheus and Slack. There is a lot to go through, and I will let my presenter do most of the work, but as a way of introduction, my name is Matthew Shear. I'm marketing manager here at Rancher. I included my email so you can reach out to me if you need help finding any resources or some other issue. So please stay in touch. Love conversation. And our presenter on the line is a cloud engineer from Redapp, Christoph. Christoph, are you there?
I am. Thank you.
All right, awesome. Christoph was showing me a little bit of what he's done before the session, so it's going to be awesome. I think there is a lot of cool stuff to learn today. I'm really excited for it. So without further ado, let's just get to a couple housekeeping items, and then we can get into the meat of the material for today. So, these sessions tend to run, we try to keep the presentation about 40, 45 minutes, often goes long because there is just a lot to go through. And we end up staying on often, 60 to 90 minutes just to get to every single question. We really try to answer all of your questions and leave without any unanswered. So if you do have questions, please start putting them into the chat. GoToWebinar is a really cool chat feature. And if you want your question to remain private for whatever reason, just mark it as such. Let us know. Otherwise, we will answer aloud for everybody's benefit, kind of as a teaching tool. And these sessions, as I mentioned at the beginning, are recorded. So if you want to view this one, you want to view any of our past recordings, we just do a ton of these. We usually have 1 or 2 a week. You can go to YouTube, youtube.com/c/rancher, and find them all there. We also do intro trainings or online meetups, and all of those are posted there. So there's just a ton to learn on, a ton of different topics around containers and Kubernetes. And if you want to get connected to our Slack, our community, please visit Slack, slack.rancher.io. Thousands of members, hundreds of people talking about these topics every day, answering questions. Our engineers are on there as well, trying to do their best to be helpful. So you can join for free. And if you want to hear about these kinds of sessions or get files that are uploaded, and slides and things like that, you can join our Kubernetes Masterclass, just pound Masterclass channel for online meetup, pound online meetup, or we also have a training channel too, just pound training. But there are a ton of channels on a ton of different topics, so please do check that out. We have a lot of upcoming classes as well. As like I said, we do one of these almost once a week, at least a few times a month. And then in July, we have one every week. So there's a ton of different topics we'll be exploring on monitoring your clusters. Our principal engineer, Sheng Yang of Project Longhorn on persistent storage, is going to be presenting about that. That should be really cool. In fact, I think we just submitted Project Longhorn to the CNCF as an open source project. So definitely stay tuned for that one. July 16th should be really good. Also, our GitLab partner, Priyanka, will be presenting Shifting Left from Wishes to Workflows about just managing all of these new tools in the tool chain. And there's just so much there around design and architecture. So should be talking about that at a high level and then going into the details of the tools. And then we'll end the month talking about database recovery, disaster recovery. So showing demos on fail-safe stuff. So that should be really good too from StorageOS. So just a ton of topics. So now that is all out of the way, we can actually get to what you came here for. So I'm going to pass this presentation over to you, Christoph, so you can get us going. Make you the presenter.
All right. Can you see my screen?
I sure can. You're good to go.
Perfect. All right. I'll start with the slides here. So as Matthew was saying, this is a webinar about the site reliability engineering golden signals. This Concept was popularized by the famous Google SRE handbook, which is available for free online. There's a link in the slide here. Just a quick introduction. My name is Christoph Champ. I'm a cloud engineer at Redapt, and Redapt does professional services. We help people move to the cloud, make better use of the cloud, or even on-prem sort of hybrid cloud stuff as well. And we work in all the public clouds: Azure, Google, and AWS. So an overview of what we're going to talk about here is the understanding how to monitor these golden signals. I will explain what these golden signals are in a minute. We're going to be monitoring these in a Kubernetes cluster, and this Kubernetes cluster is running in AWS, and it, excuse me, and is being controlled by Rancher. And I'll give a quick little overview of Rancher in a minute as well. So these golden signals are important for your day 2 operations. So I'll explain what that is as well. And the tools that we're going to be using for this, besides Kubernetes and Rancher, to monitor these are Prometheus, and we're going to send alerts to Slack. So an overview of what we're going to cover is what are these golden signals and how to apply them, what is Prometheus and how to use it, and how to monitor the signals, events, and errors and receive alerts and notifications via Slack. We're also going to use another tool called Grafana, which is a way to visualize your metrics in nice graphs and customizable dashboards, and I'll go over that in a minute as well. So the golden signals, what are they? So these 4 golden signals were popularized by Google's SRE book, which you see a link to at the bottom of the screen, specifically the golden signals section of the book. This book has been out there for a while, and it's super popular. I highly recommend reading it. They have a companion follow-up book, which is more of a hands-on practical examples of how to do SRE. And so yeah, I highly recommend reading both. They're really useful in everyday life for your operations of your clusters and your systems and so on. So quickly here, the 4 signals that Google recommends that you monitor for your day 2 operations. It said if you can monitor anything, monitor at least these 4. And the 4 are latency, traffic, errors, and saturation. So latency is the time it takes to receive a request. Traffic is a measure of how much demand is being placed on your system, measured in high-level system-specific metrics. And errors are the rate of requests that fail, and saturation is how full your service is. So I want to actually go to the source, where Google is talking about these in the chapter 6 of the SRE book. The 4 golden signals of monitoring here you can see on the screen, where they explain each of these signals in more detail. You can go to this side afterward and read this whole chapter if you'd like for more details. But as they say right here at the top, if you can only measure 4 metrics of your user-facing system, focus on these 4. I should point out that there are other signals and other systems that are not called the golden signals. There is the use and the red signals as well. You can, I'll put links to those and you can Google those as well for more details. But the ones, this is the one we're going to focus on today. And we're going to try to, because these are live sort of things, metrics that you have to look for a system that's live and that's being hit by actual users and actual traffic. Since this is for the demo, I don't have an actual website that I can, production website that I can be simulating these sort of latencies and errors and so on like that. I'm going to demo with a demo cluster, and I'm going to artificially induce some latency to actually give you an example of what you can see to actually to mimic these signals. So it's going to be somewhat artificial, but hopefully you'll get an idea of what we're talking about and the tools we're using with Prometheus and getting the alerts into Slack. So yeah, I won't go through each of these. It's just not enough time, and some of these are hard to actually simulate. So we'll try our best. We'll see how far we get, and of course, if you have any questions, please feel free to ask. So yeah, back to the slides here. Oops. All right, so Prometheus, what is Prometheus? Prometheus is an open source software application used for event monitoring and alerting. It records real-time metrics in a time series database, allowing for high dimensionality, and it's built using an HTTP pull model with flexible queries and real-time alerting. Prometheus is not only open source, completely free, and it's been out there for a while, and it's very popular, especially in the Kubernetes world. And there's a link in the bottom of the slide there to Prometheus, prometheus.io. Grafana is the other tool we're going to be using, and this is the tool, it's also open source and free, that we're going to be using this to actually visualize some of the analytics and monitoring that we're going to be seeing here. And it has a really highly customizable dashboard that you can sort of just create your own sort of dashboard of the metrics that you're interested in. And usually if you enterprise companies, you'll see them using it. They'll have like, big monitors sitting up there and just showing metrics and sort of stuff so that the ops team can be monitoring and see it in real time. And let's actually get to the demo. So what we're going to be using is Rancher. If you're not familiar with Rancher, Rancher is a way to sort of control multiple clusters, and these Kubernetes clusters, that is, they can be in any of the public clouds. It supports Azure, Google, AWS, or it can be on-prem. These clusters can even be imported from, let's say you're running Minikube on your laptop. So Minikube is a way to sort of test out Kubernetes and a small single node cluster running on your laptop. It's just a virtual machine running on your laptop. And you can actually import Minikube into Rancher as well. And Rancher, I'm using the latest version of Rancher 2.2.4 as of this recording. And it's been using Rancher for many years now, and it's a really powerful and really useful tool for managing Kubernetes clusters, and it has a whole bunch of features. We don't have time to get into all of the features. I know that the Rancher guys have webinars on various features of Rancher, and so I highly recommend checking those out for the details. So what you see here is 3 clusters that we have. We have the main cluster, the local cluster. This is the Rancher itself. Rancher is actually running Kubernetes. So Rancher itself is a Kubernetes cluster. And then I have these 2 other clusters here. And one is a custom cluster that is just these EC2 instances that I set up. So I created these EC2 instances, and then I had Rancher gives you you can add a cluster here and all the different various cluster providers that they support. The one I did was the custom one, and then just told it that I wanted to use Amazon because I'm using EC2 instances, and did some configuration stuff, and then it gives you a little Docker script that you run on the EC2 instances. So I have 3 of them here. So I just ran that on each of the EC2 instances, and then it automatically joins the cluster. So that's what you see here. This third cluster, and the one we'll be using for this demo, is a Amazon EKS cluster. This was also created by going here, clicking on Amazon EKS, and configuring some stuff, and running that, and then that created an EKS cluster in Amazon. And then after a cluster was created, it joined Rancher, registered with Rancher, and now we can actually use that. We can interact with it, that is. So if you click on this menu here and you go into your system services, you'll see that the Kubernetes system services along with these 2 Rancher agents. One is that runs on each node, and then there's the cluster agent as well. So this is how Rancher and the EKS cluster communicate with each other. And then you can go to the default namespace, or that in this case it was a project called default, but it's also the default namespace. And you can create your own namespaces, but we'll just be using a default namespace for this example. So what I did was, after setting up the cluster, I had it install the Prometheus and Grafana tools. So they're also running in the cluster. And the way I did that was by using the apps section. Now, apps are these catalog of services, different tools and so on that that Rancher allows you to import. And these are Helm charts essentially that Rancher puts a front end on. And there are hundreds and hundreds of these catalog items that are Helm charts, again, that are available, and you can add your own. And a lot of these are by default. You're going to be seeing the Rancher supported catalogs, and then there's also the community catalogs from the community Helm charts. And there's quite a few of these. And so, like, let me actually show you the Prometheus one. So Prometheus, and I'm using the Prometheus from the library here. So if you click on the view the details, it gives you a little explanation of what Prometheus is, and then go into the detailed description, and it'll give you all the different options for setting up Prometheus. Prometheus is a huge, there's a lot going on in Prometheus, and we definitely don't have time to go into all the details of Prometheus, but Prometheus is highly configurable. There's hundreds or thousands of metrics that you can observe or configure for your system. And in this one here, they're giving you showing you what the default options that they're using for some of the clusters. Some of these are empty, like this one here or this one here. These are where you would actually fill in the information yourself. If it has something filled in that's showing you what the default is, and you can override that. So there's tons of this in there, and all of this stuff is obviously free and open source, and you can actually go to GitHub and actually see the actual Helm chart that it's using. So you fill out some information here. You give your cluster or the Helm chart a name, or in this case, the catalog. I'm using those interchangeably. They're the same thing. You can choose which template version you want. In this case, there's only one. And you tell it which namespace you want it to deploy it to, what namespace in Kubernetes you want it to deploy it to. And some other options, these are these questions that you'll see in a Helm chart as a questions.yaml file that these are pulling those from. But you can actually go and actually see a preview of your Helm chart, your values from your Helm chart, if I were to fill out information. Here's the values file that is pulling it from. Again, this is in GitHub. You can just go to Prometheus on GitHub and look at the actual Helm chart itself. And you can actually see all the different files that are part of the Helm chart, all the templates and various other files that make up this Helm chart. And as you can see, there's quite a few of them that make up this Helm chart. So after you fill out all that information, you click launch, and then Rancher will go. And if I go to my apps, it will show you the ones that are deployed. So here's the Prometheus one, and these are the different ports that it's listening on. So if you're going to put this into a way that's publicly accessible, whatever your, let's say you put a load balancer in front of this, these are the ports that it will be necessary to listen on. And I'm also using the Nginx Ingos controller for the actual load balancer that I'm putting in front of Prometheus, as well as for Grafana and the other workload or the demo pod that I'm running, which is actually Nginx. So you'll see here, this is the Nginx service, the one that we're actually using for the demo. And this is just a single pod running the latest version of Nginx. Obviously, don't do something like that in production, put an actual version there, but beside the point. And in front of this pod, we have service. Kubernetes service, which is this one here. And this Kubernetes service is of type load balancer. So it will create a load balancer. In this case, I'm using AWS, so it's putting a load balancer in front of this Nginx service. And we also have a load balancer in front of Grafana and Prometheus. So Prometheus here, actually, let me take this out real quick and show you. So this is what the Prometheus dashboard looks like, but the default dashboard looks like. It's just blank, nothing really much going on. And if you want to look at a metric, again, Prometheus is running here inside this cluster, and it's gathering all sorts of metrics about this cluster, and not just about the pods that are running, but also like the services and even config maps and secrets and you name it, all the different primitives that are involved in Kubernetes, you can configure it to look at. So if you do things like update a config map and you want to be notified about that, Prometheus will gather that metric for you. If you want to see how two pods are interacting with each other, what kind of packets they're sending, any kind of latency, any errors. If you want to look at 500s or 400s or something like that, or HTTP requests, you can see that in Prometheus. But it also looks at the underlying nodes that are running on the cluster, the actual, in this case, the EC2 instances, gathering metrics on them like CPU load, memory, disk usage, IO, network IO, all sorts of metrics that you can see on the underlying nodes. Prometheus is gathering them for you. So if you want to actually look at some kind of metric, you can just start typing things like a letter here. I'm just type any letter, and you'll see like there are thousands and thousands of metrics available to look at. And these are you can customize these as well and say you can add other metrics that are not the default metrics put in there. And you can then, if I go back to the top, so for an example, I'm going to put in a query here where I want to look at an example here is a container network receive bytes total. So in this case, I'm telling it I want to look at this specific container, and I'm giving it the name, which is this Nginx service one, which is back to the workload, is this one right here. And it's using this sort of prefix here, which is the actual Docker container name that Rancher assigned to it. And the Nginx service, as this part here, is if I went to the command line and I typed in kubectl get pods. Hopefully everyone can see my screen. And I should point out that AWS was having some network issues yesterday, and it looks like it's persisting even into today. So that's why it's responding so slowly. Hopefully this will respond. Come on. Well, hopefully this is not, okay, there we go. So that normally doesn't take that long to respond. It should respond pretty much right away. But anyway, here's the actual pod in question that we're interested in, this Nginx service BTRX9. So when we execute this, we'll see that we're going to get a whole bunch of information back. But the value that we're interested in here is the metric, is the container network receive bytes that the Prometheus has gathered since it started monitoring this app. So that's the console details, but then we can go over to the graph and actually see a graph over time. Now this is cumulative over time. So you can actually say, okay, look for the last hour, look for the last 30 minutes, look for the last 2 hours, and so on. All right, but this is interesting, but it's not as valuable for what we want to see, because we're more interested in the sort of the real-time stuff. I mean, this is useful for seeing historical and so on, but we want to get alerts happening when when in real time. And so what we're doing is we're going to use Grafana, and Grafana is going to ingest all of this information from Prometheus and display it as these graphs. So what we have here, actually, we'll go to back to the. So if you go to Prometheus and you, sorry, not Prometheus, go to Grafana's dashboards, you have a whole bunch of different predefined dashboards. Not all of these were predefined, but you have, for example, this nose one here, and it's giving you information on, memory usage, disk I/O, disk space, and so on. These are all just sort of default ones, and it's looking at, this is like a dashboard that you could have running on like a big LCD screen in your office, and just kind of showing you what's the state of your current system. But then you can also create your own dashboards or add panels to these dashboards, or you can also import predefined dashboards that other people have sort of released to the community, open source. So you can go to the Grafana dashboards website and import dashboards. So one way you can do that is go new dashboard, and you can go to choose which kind of panel you want to create. And there's all these different types here, and you can actually define your own as well. You can say something like, I want a graph like that, or the charts and so on like that. But what I did is go to the import dashboard, and I put in the URL, or actually the dashboard ID of the dashboards that I wanted into here, and then I imported it. So if I go back to my dashboards, the one I'm going to be using is the Kubernetes cluster monitoring by Prometheus. This is a community created dashboard that you can put here on, and it will give you Kubernetes related panels for your dashboard. So what you'll see here are all the different pods that are running on my cluster, and this is all real time. These are their CPU usage for 2-minute averages, and showing it for this period of time from 1020 to 1020 or 1022 to 1027. And if I wanted to say, okay, I just want to look at a single one, so let's say, I don't know, let's look at, I'll just look at the Prometheus one. So here's the Prometheus one, its CPU usage over time, and so on. So then I can create alerts on these metrics, and I can say, if this CPU usage goes over a certain amount, then alert me, and you can decide what kind of alert you want it to be. Do you want an email? Do you want a Slack alert? There's all different types of alerts that you can choose. And the way you do that is you come into your alert system and you set up your notification channels. And here I have the notification channel called Grafana for the type of Slack, but I could also create a new type. I can say an email, I want PagerDuty, Microsoft Teams, Telegram, Sensu, you name it. There's a whole bunch of them in there. And so for the purposes of this demo, we're just going to be focusing on using Slack. And then after that, you go back to your dashboards, and choosing the dashboard that you want, we're going to say, let's create an alert. So what I'm actually creating alert on in this example here is going to be on the pod network IO. So I click on this and I edit this panel in this dashboard, and down here I'm specifying the metric that I'm looking at. In this case, I want it to sum the rate of the container network receive bytes, and down here is the transmit bytes, but in this case I'm doing the receive bytes for the name, which in this case is this pod, the same pod that we're looking at in Prometheus. And I'm telling it to, I know which host this pod is running on by doing, hopefully this will respond. Yeah, so here's the host, the node that this pod is running on. So that's what this is here. And I wanted to look at 2-minute average, and I wanted to create metrics for that. So after the metrics are created for that, I then say I want to be alerted on something. So I'm telling it here to evaluate every 10 seconds, and this is configurable. You can make it 1 second, 1 minute, 1 hour, whatever. So I wanted to evaluate this incoming from Prometheus, these metrics, every 10 seconds, and I'm interested in the Nginx service. And there are two metrics for the Nginx. One is the transmitted and one is the received bytes. And if you go back to metrics, you'll see that I have A and B, and I can add more metrics, but in this case, I only have A and B. So I'm telling it I want it to alert on A because I want it to show me the container network receive bytes. And that's what that is. And I'm querying every 10 seconds, and from every 10 seconds, previous 10 seconds to the previous to the now part. And I want to alert when the max of these incoming bytes is above 6,000 bytes per second. And then I want it to alert whenever this goes above that. And you'll see this right here. This is the alert up here, and right now it's receiving 0 bytes per second. And I can actually test the rule to see that my rule is working, and it's going to actually receive some data and so on. So right now it's saying the condition to eval is false because it is not more than 6,000 bytes per second. But we can simulate that we are receiving that. So what I'm going to be using is a tool called Apache Benchmark, or AB for short, which is a command line tool. And if you're interested, you can go to this link, which is also going to be provided to you in the email that Matthew will be sending out. And Apache Benchmark has been around for many, many years, and it's a tool that I'm sure if you're a developer or ops guy, I'm sure you've heard of it or used it before. But it's a way to actually simulate traffic and load on your website to see how your website responds to load. So for an example, I can come here. Oh, and I should point out that my Nginx service is running it has a load balancer in front of it. It's an ELB load balancer in AWS. So if I curl this website, you'll just see it responds Christoph tested. But what we want to do is simulate that we're putting load on this. So I'm going to do, if you do AB, you can actually do a man in AB as well to get information on what you want, or you can just do AB help, and it will give you all the different options for you. There's a lot of them out there. We're going to be using the two most common ones, these two top ones here. So we're going to say -n, and then we're going to give it an integer value of the number of requests we want to perform, and -c for concurrency, for the number of multiple requests to make at a time. So what we'll do is, using the same URL here, we're going to say AB, and we're going to simulate, I don't know, 2,000, and with a concurrency of 100. And whoops, sorry. And then we're going to hit this URL. So when you do this, we'll start hitting this. So it's completed 200 requests, 400 requests. Now if we go back to Grafana, we'll see that it's starting to notice that load is starting to go up. And hopefully we'll get it to go over 6,000. And if not, we might have to increase the number of requests to get it to go over that. I don't think 2,000 is going to do it, so let's increase that. So we're going to also say number of concurrent connections, why not 300, and make this, I don't know, 4,000 or 5,000, why not? And if it doesn't for this demo, because right now there it goes, it's gone over 6,000. So we should start seeing alert pretty soon, and there it is. So you see this red line here? That red line said, we're alerting because it's received over 6,000, or it's over our threshold. So now if we go to Slack, I have my Slack channel called Prometheus, and it alerted me saying this pod Nginx service, and here's the bytes, number of bytes per second it's receiving, 15,000, and it alerted me because it hit my threshold. But this thing has stopped running, and it's it looks like it didn't like it with that many connections, so that it wasn't able to handle that many. But in that case, you would use something like a horizontal pod autoscaler or something like that to actually allow it to scale when it starts receiving that many. But anyway, so the point was we're trying to make it trigger this alert, and that's what I was doing with this artificial number of requests coming in. So when this goes back down below, there it is, that green line, which is saying now it's back down to okay. We have it alert again saying, okay, everything's good now. So that was just on one metric. We can do all sorts of other metrics, but we can also use another tool, which is also used a lot by ops people. And this is a more technical one. This is this link will also be provided to you, but the command we're looking at here is this one called TC, which is traffic control. It's a Linux command line tool that allows you to simulate things like packet loss and latency, the things that you want to use in your golden networks, golden signals. So you can actually simulate these sorts of things so that you can test your system. How does it respond to these different types of errors or latencies or packet losses, and see how resilient your system is. It's also useful for testing your Prometheus and Grafana alerts so that you can actually, so in this case, this one here, it's actually creating, it's telling it on the device of ETH0, I want to introduce some latency of 400 milliseconds. So for an example, if I go to, sorry, make this a little bigger. If I go to my Rancher Bastion host and I go to here, I have this little script where I'm calling TC to add a delay. So this command is telling it, so if I do IPA, you'll see that I have my main device is ETH0, and I want to add to the ETH0 a delay of 100 milliseconds. So for example, if I were to ping this endpoint, you'll see that it's, sorry, it's moving this up a little bit there. You'll see that it's this MS here, 7.2 milliseconds, so very, very fast. But let's simulate, let's simulate by adding, using TC to add a delay of 100 milliseconds to this endpoint, or sorry, to this Ethernet device. So if I just run that command, and now it's limited, and if I come back to my ping and I run this again, we'll see that it went from 7 to 107 milliseconds. So this is useful for when you want to simulate some latency on your network. So what you would do is you would do this on one of your nodes in your Kubernetes cluster that's running the pod in question. You'll run this, and it will introduce some latency. And then you'll have other pods on other nodes that don't have this introduced latency, and you'll have them try to reach. So I could be having a pod just doing sort of like an A/B test on Apache Benchmark test on my the Nginx service pod, where the Nginx service pod is running on a node that has this introduced latency. And then I should be able to see the latency in Prometheus and Grafana and be able to alert on that. And that's a way I can test my system to see how it responds to that. I can do the same. So this is just for latency, but I can do the same for packet loss. But before we do that, what you should always do is remove that. So there's a delete to do the exact opposite of where I was doing. So add. So here I'm adding this delay, this latency, and here I'm deleting the delay. So if I TC delete, and now I do the ping again, you'll see it's gone back to its normal latency. So that tool, which TC, which is super powerful, and I've only talked about or just showed you how to introduce some latency, but there are tons of options that you can do. You can do all sorts of stuff, latency and jitter and packet loss and corruptions and all sorts of stuff. Super, super useful for testing your system and see how it responds and works with And this is not, here I'm just showing it for simple networking stuff, but you can do packets, drill down, and if you have something like TCP dump running in the background and capturing the packets and then bring that into Wireshark, you can actually follow exactly where the packets were lost. And all of that stuff can then, of course, be ingested into Prometheus, and then you can create graphs on it and actually see that stuff happening in real time. So it's a great way to test things. How are we doing for time, Matthew?
Oh, you're good. Keep going. There is a couple questions. Do you mind? Actually, there's just one. It's from Herman, who asks, is it, and you might have shown this already, but he says, is it possible to show the URL for dashboards to import?
Oh yeah, sure. So if you actually just Google Grafana dashboard, this one here from Grafana Labs and dashboards, it's going to have all these different dashboards, and you can filter it by what you're looking for. So for an example, we want to filter for Prometheus, and let's say a panel type. You can choose whatever type of panel you're interested in: heat maps, bubble charts, whatever. I don't know. Where is that heat map? That one might be interesting. And we're going to say we can choose what category we want it to look at. All these different categories. Let's look at AWS, and we want the collector, which type of collector we're going to use. We're going to just look for whatever. So we just as an example, I don't know what this one is, but we'll say let's import this dashboard. So there's two ways you can do it. You can actually import by the URL. You can actually download the JSON. These dashboards are just JSON files. And an example of that is Grafana Nginx, which I am using. It's just a JSON file that gives you all the information about the dashboard, including the size of the dashboard, the color of the different things in the dashboard, and the metrics you want it to pull from in here. Here's a metric that I'm telling it to pull from Prometheus. I want this, just as I was showing you before in Prometheus where I was doing this query. You can do this exact same query or describe this a query in this JSON file. And there's a whole bunch in there. So I can now download that JSON file and then upload it to Grafana, or I can get this dashboard ID here, which is 3434. So if I come over here and I go to import on my dashboard, I can put that 3434, or I can paste the JSON in here, or I can upload a JSON file. There's all the different methods you can use, or I can actually put the dashboard, there's a dashboard URL. So let's say this dashboard was stored in something like GitHub or something. So if I load that, I tell it, it tells me a little bit of information about it, and then I can tell it what I want to call it, and I'm telling it where to get the data from. In this case, I'm getting it from Prometheus, but Prometheus is probably not going to show anything because we're not running anything related to this dashboard. But anyway, so I import it, and there's the dashboard. Now that the dashboard is there, I can actually start, I can drag things around, or I can resize things. Like I'll say I want to make this, I don't know, smaller for it to fit on my screen or whatever like that. And then I can go into each one of these and I can edit, and I can actually edit the metric. And this is exactly what I was doing on the packet loss one, bytes received, excuse me. But I can customize this to however I want it. I can say I want the colors, I want the axis, I want it to be exactly here on the panel. I want the legend to look like this. I want it to be on the right or on the left. I want it to display all these different ways of configuring your panel. And these are called panels. The whole thing that we're looking at here is the dashboard, but then they're in the dashboard, there's specific panels. And you can add and remove panels as you like. And I can tell it I want the time range, and I can set it here and so on. So when we go back to the actual one we were using, which was this one, you'll see this where I select the metrics. This uses this query language, which is somewhat unique to Prometheus and Grafana, but there's tons of documentation out there. So if you go to Prometheus, actually I have it open right here. If you go to Prometheus and you go to the docs, it's going to talk about this PromQL, this flexible query language, which is what I was using in Prometheus right here. This up here, this is PromQL. So you can think of it kind of like SQL-like, not really, but it's query language that's unique to Prometheus, and it is a bit of a learning curve, but the logic is, it makes sense once you you look at this and it kind of says it makes sense. Like if I go over here, I mean, hopefully it does, but you'll see, it tells you what metric you're interested in, and then you can filter. I'm just doing a simple filter. I just want to filter on the name of the container, but I could filter on, if I actually execute this, I could filter on, I don't know, the instance type, or what type of failure, or it depends on what metric you're looking at. There's all sorts of things you can filter on, but it's very powerful, and you can string a whole bunch of things together. For an example, in this case, they're looking for all these three environments. You're filtering on all three environments here, and you're looking for any HTTP request that is not GET. You can do regex on it. Anyway, it goes on and on. It's way outside the scope of this webinar, but if you are interested, I recommend checking out their docs. They're really great. And of course, you can always just Google around, Stack Overflow and so on. There's plenty of examples out there. But anyway, this same query, PromQL, is what I'm using down here in my graph metrics for this graph up here. And so I'm telling it I want it to sum over the rate for this pod and on this host for the last 2 minutes. And that's what you're seeing up here. Any other questions?
There are a few now coming in. So do you want to take these now, or do you want to show us more first?
No, I'll take them now. I mean, that was pretty much the demo there. So
okay, all right, fantastic. All right, let's get to these questions then. Okay, so this is from Chanikia, who says, I'm just starting to use Kubernetes and I observed this issue. The response time on the CLIs in Kube is 3 minutes, whereas the same is less than 2 seconds in on-prem. Any idea what the issue could be?
So the Kubernetes clusters, 2 clusters, one is running, or is it the same cluster?
I think it's the same cluster. We might need a little bit more clarification to answer the question.
Yeah, if you're running what you saw when I was running here, kubectl, and I have an alias here just so I don't have to type out kubectl. When I did this, you see this right here, that response time. So that was going all the way out to AWS to query the Kubernetes API for a response. And here I'm telling it just to give me the pods in the default namespace. So you see it's responding fairly quickly, but every once in a while, or as you saw earlier in the demo, that was taking a long time to respond. Now that could be an issue on the AWS side, where they're having some networking issues like they were having last night, or it could be a networking issue on your side. And I mean, really, it's difficult to tell because it could be on both sides. One way you could do it is try to ping the API server if it allows ICMP, but it's hard to tell why it's taking so long. It really depends. Sorry.
Yeah, no problem. And Shanika, you could ask that question on our Slack too, and you might get more help there. Okay, here's the next one. It's from Lewis, who asks, what do you suggest for monitoring several clusters with Prometheus in an HA and secure implementation? Something like Cortex, maybe? What do you think?
So monitoring multiple clusters with Prometheus is actually pretty easy to do in Kubernetes. So let's say you have, in this case, here's an example. So I have 3 different clusters here. in Rancher, I don't have to be using Rancher, but in Rancher, I could just go into each of these clusters and install Prometheus, like I did for this one here. Go back here. And when I go to the apps, I have Prometheus is installed here. And it has this endpoint, which it creates by, in my case, I put a load balancer in front of it. You don't have to, but I put a load balancer in front of Prometheus. And if you look at here, here's the Prometheus load balancer, which is actually an ELB in AWS. And then that endpoint is, I can have them sort of all pointing to sort of a one Prometheus sort of ingester. So there's different ways you can do it. One, you can have 3 different Prometheuses and then just have one Grafana, which is ingesting from all these different data sources. So you just tell Grafana, here's the Prometheus for the first cluster, for the second cluster, for the third cluster, and I make different dashboards, or I can have one dashboard with different panels for the different clusters that are just pulling from the different Prometheus endpoints. I think that's the way I would do it. You could also come up with more complex ways of having a single Prometheus dashboard that is ingesting from multiple clusters, which is fine. And but of course, you would want to make this HA, and in Rancher, that's very simple. You can scale up your Prometheus. Right now, I'm running 1 pod, but the node exporter is running on 3 pods. So I can just say, instead of 3 pods, let's run 5 pods of this. And let's say in my cluster, I have 5 nodes. I can tell it I want 1 pod on each node. Therefore, if a node in the cluster goes down, I still have this backup. And so that's how you can make that HA. But you have a single sort of load balancer that's in front of that, so that you don't have to update that, and you just have that load balancer endpoint. But in the background, there are multiple pods running on multiple nodes to keep your Prometheus cluster HA. Does that answer the question?
Awesome. Thank you. That's great. Okay, here's the next one. This is from Herman, who asks, what size should be used for the persistent volume Prometheus uses?
Great question. So it depends on how far back in time you want to store your metrics. It also depends on what kind of metrics you've installed into Prometheus. So if you go to the Prometheus configuration, which is highly configurable, you can tell it this up here, there's this global sort of scrape interval, but you can actually go down in and tell it, drill down and say, for this metric, I want you to keep 30 days of data. For this metric, I only care about the last hour, and so on. And depending on what you configure, it's going to use more or less disk space. And those in Prometheus were, it's, in my case right here, I was telling it I don't care about persistent data because this is just a storage. This is just demo. But I could also create persistent volume here, and this persistent volume is just and for AWS, it could be something like an EBS volume or an NFS share or something like that. And I just mount that on my cluster, and I point Prometheus to that and tell Prometheus, I want you to store your data on there. And then, of course, if it's persistent and it's EBS, it's elastic in AWS, you can just have it say, just keep scaling up as my data starts filling up, and so on like that. And you can rotate it out. You can back up your Prometheus data into something like an S3 bucket for long-term storage. And in fact, that's what I would recommend to do. But to tell you what size it should be is there's no real answer. It really depends on how much data you're wanting to keep, how far back in time. All of it is completely configurable. So one of the things you do, or I would recommend to do, is just start your monitoring with a EBS volume. I don't know, give it data is cheap in AWS and all the public clouds, in fact. So, just start with the EBS volume of, let's say, 100 gigabytes, and then run your metrics in real time in production or whatever you want, or wherever you're wanting to test this, for a couple of days, a month, or something like that, and see how much space it's using. to give you a gauge of, okay, so after a month with all these metrics, this is how much disk space is going to use, and I want to keep this data for a year, so multiply by 12, and that's how much disk space and then add some buffer space, in case there's some crazy alerts going off or something like that that triggers more metrics. And these metrics, even though there's thousands of them, they're also just text. It's just text in JSON, so it's really small. So it's lightweight. So, but yeah, just kind of gauge it, get an idea, but let it run for a month and get an idea how much disk space that a month of data used, and then just kind of gauge it like that. And I mean, that's how I do it. There's no real rule of thumb.
Cool, awesome, thank you for that. Okay, here's the next one. This is from Dhruva, who asks, we can set up alerts in Rancher, in Prometheus, and also in Grafana. Are these all the same? And what is the best place to set them up?
I would recommend Grafana. You can set up alerts in Prometheus, and you can actually use different alerts systems that you want for Kubernetes. And you don't have to be using Prometheus. Prometheus, there's tons of tools out there for ingesting information. There's proprietary ones or paid ones like Sumo Logic or Dynatrace or whatever like that add maybe some more features, and they manage the cluster for you, but you're paying them for it. So it just depends on what your needs are. If your company is okay with managing the Prometheus and Grafana servers, which you do have to manage. They're free and open source, highly configurable, but there's that added burden of having to manage the clusters. What if the cluster goes down? Do you have to back up? If you have to upgrade Prometheus? If there was some bug or something and you need to upgrade, how will that affect you in production? And how would you manage that? Or versus using something like a paid managed service where they're going to manage that for you and you don't have to worry about it. It's sort of that age-old question, where do you want to have everything on-prem, or do you want to put it in the public cloud? So, but in my case, if I was in this situation, I would set up the alerts in Grafana. They're really easy, and you can see it in real time, and you can watch. It's a really easy way. You can also set them up in Prometheus. It's just not as user friendly, and it doesn't look as visually appealing. To put it another way.
Awesome, thanks, Christoph. Okay, here's the next one. This is from Shri, who asks, is there a way that I can execute a command and/or a script when there is an event that occurs?
In Grafana, I assume he's asking for Grafana.
I think so. It doesn't specify.
Right. So not that I'm aware of in Grafana itself, or even in Prometheus. However, with these alerts, you can create. So I'm just using Slack, which has this sort of a webhook, and you can have a Slack bot that will respond to an alert like this. So let's pretend that the alert was something like, your disk space is filling up, and from experience that the disk space is being filled up is most likely going to be because var log files are filling up on your disks. So a common thing that you do in ops is you're going to, disk space is filling up, you're going to log into the server, and you're going to look at the var log file, and you're going to notice, okay, yeah, we got a whole bunch of cached logs or whatever that we don't really care about, so we're going to delete them, or we're going to move them off the server, back them up somewhere else or something like that. All of that, of course, could be automated, and you can have it such that when you get an alert from Grafana and you push it to something like Prometheus, you could have a chat, or you could have a Slack bot that says, oh, I know what to do, and it goes and does that. Or in the alerts, remember in the alerts that we could use different alert methods, and I chose Slack, but we don't have to. We could use a webhook, and that webhook can be interpreted or used by a Bash script or a Python script or whatever you want to use. So it's just sitting there looking at that webhook. It's just listening So if you had like let's say a Python listener and just sitting there on that webhook and says, oh, I got alert, and then the Python deals with the logic. Oh, okay, this alert means do this or try to do this. And if not, I can't fix it, then send an alert back to Slack saying, hey, I tried, but it didn't work. Now need a human intervention. That's the way I would do it.
Fantastic. Okay, thank you. This is the next one from Nadir. Are these golden signals included in Rancher built-in monitoring?
They are not. Golden signals are super, it's almost like an art. There is no, I mean, obviously there's a bit of science behind it, but it really is, to really get it to work right, it is an art, and it is something that you have to kind of massage for your specific applications, for your website, whatever it is that you're monitoring. And you have to customize it, and you have to really know your system. This is something that this is not stuff like capacity planning, or before we go into production, we need to know how much RAM or disk space or memory or CPU or disk space or IO that we need for our application, for our website or whatever it is. So we plan for all that, and we know this is how much we're going to need. And when we go to production, we're going to check for alerts for this. This is not that. This is stuff that you really, it's not something you can really plan for. It has to be tested live. And I don't mean live as in production. You can test it in your QA or staging environments, where you're hitting it hard, like I was doing here with these different tools like TC and AB, various other tools they can use, to actually go through and test for all these different scenarios, for all these different golden signals, and just kind of see how your system responds and know what is normal and what is not, and then set up the alerts based on that. It's an art. There is no way of telling you, hey, do this. It completely depends on your system, completely depends on your apps and how they respond and how you want them to respond. But you can only use these metrics correctly by testing.
Right. All right. Thank you. Okay. Here's the next one. And by the way, thanks everybody for your questions. There are quite a few more to get through. So thanks for your patience. And Christoph, thank you so much for answering these.
Absolutely.
Okay. Here's the next one. Can we integrate Grafana with ServiceNow for incident creation?
So I don't know the details about that, but you can integrate. You can tell Grafana or Prometheus. Not only, okay, so what I was using Slack or something like that. These are the default integrations that they have, but I'm assuming you're saying like, okay, if this alert goes off, create a ticket or something like that. I assume that's the question. So what you could do is build the logic around that by having this webhook. Where is it? Webhook here. And the webhook is going to be something that you're going to have some process of creating the ServiceNow ticket via this webhook. There might be, I don't know off the top of my head, but there might be an actual integration for Grafana and ServiceNow, so that you don't have to use a webhook. You just have another integration right here for ServiceNow that it will automatically create the ticket.
Right. Okay. Cool. All right. Here's the next one. This is from Samit. Can we monitor pods in specific namespaces and the traffic coming to this namespace only?
Absolutely. So when we come back to this here, what I told it is I'm looking for the traffic coming, the receive bytes for this pod, but I could say instead of this pod, I could, back in my Grafana thing, I have an example where I am, sorry. So here's all the different pods and all the different namespaces. But if I were to edit this, I could say right here, this regex is saying, look for all pods that start with K8S underscore. But I could also say, instead of just the name of the pod, I could say the namespace and say, and here I'm doing the host here. So I'm saying, looking for all pods on this host. on this node, this one cluster node. But instead, I could say look for all pods in this namespace. So it's PromQL, so it's just the Prometheus QL. So it's highly configurable, and you can query off of anything that basically, essentially, any Kubernetes primitive. So if I did kubectl get pods, and here's where I was getting the host that this pod is on. But I could also do it for a config map in this namespace, or a secret in this namespace, or a config map that starts with, you know, foo in namespace that starts with bar, you know, things like that. It's completely configurable.
Fantastic. Thank you. Okay, here's the next one. This is from Lori, who asks, can you have a webhook alert and a Slack alert at the same time? In other words, can you have multiple types of alerts for one metric?
Well, so you can create multiple types of alerts, but what you're creating the alerts on is for a specific panel, and that specific panel is going to alert based on a condition, but it's only alerting on what you're setting the alert to go to. However, if you wanted it to alert to Slack and a webhook, what you could do in a simple way is to create a clone of this panel and have it everything be exactly the same. So you just clone this panel, but you have it alert to something else. So over here, my notification channels, here I have just one for Slack, but I could add a new channel and have it be for a webhook. And then when I go to my dashboard, in my alerts, metrics, edit this, I can, where are you? I can tell it to alert to the other notification channel. So here I'm alerting to Slack. I can tell it to alert to a webhook or ServiceNow or whatever. Hopefully that answered the question.
Cool. Okay. Thank you. Yeah, if it didn't, Lori, just ask a clarifying question. Okay, this next one's from Michael, who asks, can you show an example of how to monitor percentage of failure? Is this essentially monitoring the monitor?
Percentage of failure in what? So like of anything? If of anything, yes. So right here, I'm just doing the sum of the rate, but instead I could do a percentage. You can do some simple, you can also do some simple math. Here I'm doing the sum by pod. So here you see each pod is being summed. It's network, right, where is it? Right here, the container network receive bytes. So, you know, when I click on each one of these, it's summing over each one. But I could do a percentage, and here I'm just doing container network transmit bytes, but I could have do, you know, something like packet loss, and I could do percent packet loss, and percent of what. So you say, well, I normally am at X, and so do this query down here, do percent, say I want to look at 75%. Or if I know how much disk space, let's say as an example, I know how much disk space I have and I want to do a percent of the disk space that I'm used and I want to alert on that, then you just query in your query here for your metric, you just do the math on that, saying I know I have 100 gigabytes when I'm at 75% capacity, I want to be alerted, so you just put that here in your query and then you alert on that.
Okay, all right, great. I'm just scrolling through these questions to see if there's any that we have missed. Let's see. Oh, here's one. This is from Brad, who asks, what are some container and or application level monitoring tools that integrate well with Kubernetes and Rancher?
There are tons. So, you know, ones that come to mind are things like FileBeat, Datadog, Logstash. This stuff can also be integrated. It integrates well with like an Elk stack. So Elasticsearch, Logstash, and Kibana. I just happen to be using this Prometheus and Grafana, but there are other tools out there. Now, Prometheus and Grafana, you can also tell Prometheus to, which I am not doing, but you could also have set up what are called the concept of what's called sidecars in pods. And these sidecars are just little containers that are running inside the same pod as your real container. So here is Nginx. There's only one container in this pod, it's just Nginx, but I can put a sidecar in that container, sidecar in that pod, and it just sits inside the pod and it collects, collects metrics, whatever metrics I want from the actual Nginx container. And then that sidecar will then send that data to wherever I want, to the Elk stack, or you can send it to Prometheus, and so on. And again, highly customizable, and there are tons of open source options out there, as well as paid ones. Definitely recommend first checking out the open source ones to see if it has what you need. And then, if there's something it doesn't provide all the stuff you need, then look at the commercial options to see if they. But start with the open source, get an idea of what kind of metrics you want to look at, and then if it doesn't fit your needs, go to look at the commercial options to see if they have what you're looking for. And if they don't, sometimes these guys will actually say, oh well, we'll actually create that for you, and of course it's still paid, but that's an option.
Oh, great. We're coming down to the last couple questions, comments. This is a follow-up from Lori about the question on two different alerts for the same metric. And the comment is, thanks for answering my question. I definitely think you should be able to configure an alert to notify Slack and then one of the other methods to say open a ticket using an email or webhook. I don't want to have two identical panels on my dashboard. What do you think?
I agree. And there might be, I haven't actually done what she's trying to do, but I'm positive there's a way to do it. I just don't know off the top of my head. I was just thinking off the top of my head when I said create two panels, because I know that will work. But of course, obviously, that's not really what you want to see. You don't want to go to your dashboard and see two identical panels. Of course, I mean, you can sort of minimize the panels so you only show one of them like that. But I agree, there is probably a better method. I just don't know off the top of my head.
Right. Okay, no problem. All right, here's the next one from Renko, who asks, can you give examples of sensors for I/O load, IOPS per second, persistent storage, and/or megabyte transfer rates for containers?
Sorry, I didn't quite understand. Could you say that again?
Yeah, I'm actually gonna, I can read it again, and also if you go to the chat, the questions chat, you'll be able to see this question. It is, the answer is, I've listed as you, and it is marked as a medium priority. Do you see this one from Renko?
I'm sorry, where do I look for that?
Just the questions tab. Otherwise, I'm happy to read it again.
I see the questions. What is the title?
It starts with, can you give examples of sensors?
Right. So this is what I was talking about with those sidecars. This is exactly what you would use those for. There are things like Datadog and Logstash and FileBeat and things like that that will do exactly that, so that you could run these. Now, of course, obviously, you could run sort of your own little whatever script or whatever you want, agent or whatever inside your real container, inside that pod. For an example, in Nginx, that would just be spitting out the information to standard out, standard error, that you can have Prometheus ingest. But there are more sophisticated tools or things out there where you would use something like a sidecar. So if you were to Google Kubernetes pod sidecar, and it will give you, like in their docs, they have some really good information on sidecars, but you could also Google Kubernetes sidecar, I don't know, metrics or something like that, and how to monitor advanced metrics for Kubernetes and pod deployment. Here's a great, yeah, these guys, DigitalOcean has a really great documentation. So this gives you some information. This is just first Google that a search I did and so on the kind of metrics that you can look for or use with sidecars. Here's another one from CoreOS, yep, on Prometheus operator, perfect. So giving you some information on what you could use to give you a real life example of a DNS mask metric sidecar. Here's an example. Look at the actual code. So sidecar. So oh, this thing is not too much. Anyway, I'm just this is just, you know, Googling around, but Google around for Kubernetes sidecar metrics, and maybe even put in Prometheus and so on like that. And there are lots and lots of good examples out there that will do exactly what you're trying to do.
Great, thank you.
Sorry, not a terribly useful answer, but
yeah, it's all right. Okay, I think this might be the last one. This is there a way to group metrics by Rancher project?
Yes. So the problem is, by default, it won't. But what you need to do is install so in this configuration up here, I'm telling it to just look at this one Rancher project in this case, which is the default Rancher project. So Prometheus is running in that one thing. Now, the Prometheus will only know about this one namespace, this one project. But what you could do, now there are a couple of ways of doing this. What you could do is have Prometheus run, and it's not a very, doesn't sound like the right way to do it, but this is one way you could do it, is you could have Prometheus running this Prometheus node exporter and state metrics, these running in each namespace, or in each project, sorry, but just one Prometheus server. So you just have the node exporter, but it's one Prometheus server, but this node exporter is running on each project, and then that they're just pushing that, because this is just an API, and so it's just pushing metrics for the HTTP pull and push methods. So just have that node exporter running, or the state metrics running on each project. But there's also a way to configure Prometheus to actually look at different namespaces. The problem is that these projects are meant to be isolated in Kubernetes and Rancher. That's sort of the whole point. And so the only way really to get it to work the way you want it is to have these Prometheus running on each project and have all those projects talk to the same Prometheus server endpoint. But again, the whole point of these projects in in Rancher is for isolation. So you'll have to jump through a couple of hoops and do some configurations to make it to work, because it's not supposed to work, or it's not that it's not supposed to work, but it's really meant to be isolated. So to make it to work, you just have to kind of configure it to be able to talk. I know it's again not a great response, but and something I actually haven't done before, but I know I've done it for a similar sort of thing, to be able to get it to work. It's a little complicated. You have to get the DNS rules working and all that kind of stuff to be able to talk to the different projects, but it's doable. It's just not, I don't know. It's not something I've done before, and it's not something that I mean, I guess I can understand what you're trying to do, but if you really need all those metrics, if you really want to look at metrics from different projects, just have different dashboards. That's what I do.
Right, that sounds a lot easier. Okay, here I think might be the last one. This is from Herman, who asks, can you use Prometheus on a Containerd host?
On a Containerd host. So, I mean, as in Containerd is running, is what Kubernetes is using as the underlying instead of Docker? I assume that's the question. And if so,
Yeah.
yes. And if so, yes, you can definitely do that. In fact, one of my clusters is running Containerd.
Okay, terrific. Well, cool. Well, I think that is all. I don't see any other questions. So is there anything else you want to show us, or any last messages you want to leave us with, Christoph, before I show the last couple of slides?
So not really. I mean, I would recommend, just again, to highly recommend reading this book in its entirety, not just this chapter. But if you're just interested in this part, this whole chapter, chapter 6, monitoring distributed systems, it's a great read. Definitely, if you're interested in using Prometheus and Grafana, go to their website, their docs, and they have really great documentation on their product. One little sort of got you maybe is that it is not, Grafana is easy. I think it's very intuitive. Prometheus is not as intuitive. It takes a little getting used to, and it's its own kind of world, its own little query language. So it might have a little bit of a learning curve, but once you get it, once you've played with it a bit, you'll understand the logic. It's made by engineers for engineers, and it kind of makes sense. It's just that getting over that first little hump of what exactly is this doing and how do these queries work. But after you get that, once you start looking at these kind of queries after a while, you can just you don't even have to Google for it. You can just start saying, okay, I want to look for something that starts with an E or whatever has an E in it, and I kind of already know what I want to look for, and so on. But yeah, that's about all I had to say.
Okay, fantastic. Thank you so much. I am just going to take the presentation back just to show these last couple slides.
Sure.
And let's see. All right. So just to leave everybody, just who are new to Rancher, I did know there were quite a few people asking questions who were new. So Rancher is totally free, open source. Get started. All you need is a Linux host running with Docker, and then you can just start the server with one Docker command. Rancher, as I said, it's 100% free, totally open source, enterprise container management platform built on Kubernetes. And it really, offers for, the developer, DevOps people, and for operations in IT, just lifecycle benefits, makes your life a little bit easier. There's a lot of built-in features, too many of which to go over here. The cool thing about Rancher is that, you can run it from any cluster, whether it's AWS or GCP or your custom cluster, and it'll still work just fine. If you're curious about giving Rancher a try, we do an intro training every Thursday. So I think I mentioned that to a couple of people in the chat, but the training's at the same time as this one, just every Thursday, and one of our engineers is on there going through a demo, showing you how to install and configure Rancher, import clusters, all that sort of thing, and then set up these different features around monitoring and logging, do different policy management, and a lot of cool stuff. If you want to get your own instance of Rancher going, you can just go to rancher.com, click the deploy button in the top right, and it'll bring you to the quick start guide, and you can get up and running in just a couple minutes. And we also have a lot of other open source projects and products at our github.com/rancher, our operating system, Rancher OS, RKE, lightweight Kubernetes distribution, and K3s, K3OS, and many other things. So please check that out. And we just really want to thank you for your time, for your fantastic questions. There is a survey at the end when you leave. If you're able to take just a couple minutes to fill that out. It helps us develop new content and see really what you guys want to learn about and what we can do better. And if this was helpful training for you, it'd be great to get a little shout out on Twitter. Just use the #PoundRancherTates hashtag, and we'll be able to respond to you there. And as I said, there's a lot of other sessions like these pretty much every Tuesday. So hope to see you again. And this session was recorded, so you will get a copy of that and the slides and some of the extra links that Christoph provided us in a follow-up. And that's it. Thanks, everybody. Have a great rest of your week. And Christoph, fantastic job. Thank you so much for your work and answering all of our questions.
Thank you. Have a good day.
All right. Talk to you later. Bye, everybody.
Bye.